Here's an example of a percentage abundance problem. It's giving us two different isotopes of lithium. Lithium-6 means the atomic mass of this particular lithium atom is 6, and lithium-7 means this particular mass of this lithium is 7. These are the actual masses. So notice here how in the notation it's just a number rounded to the nearest whole number. So both of these numbers rounded to the nearest whole number is where we get our notation from. Over here, these numbers are represented by the percent abundance. And when I say percent abundance, it means the percent that it is found in nature. So overall, of all the lithium we have found in nature, about 7.59% of that is lithium-6, and 92.41% of that is lithium-7. So how we calculate the weighted average, I'm going to write that out so you guys can see that, weighted average. This is very similar to how your grades are actually calculated. So notice how we have two different values and they are weighted in two different ways or given two different percentages. It's just like your grades. You have 70% of your overall grade is your test and quiz average. And then 30% of your overall grade is your homework, classwork, or in my case, your I&B average. So that's essentially what you're calculating here. And it's done in a very similar way, almost identical. So I can show you that in a later video. But first I want to show you how to find the percent abundance of this. So what we're going to do is, once given the percent abundance, we're going to find the weighted average of lithium. And how we do that is pretty much taking our masses, multiplying them by our percents, and you do that for each one. Then you're going to take the total, add it together, and that's going to give you your final answer. So let me show you. Let's go ahead and actually work out an example. We're going to start off with about 6.015. I don't want to use all those decimal places, but if you want to, that's fine. I'm going to multiply that by the decimal version of this percent. So I have to move the decimal place over twice. So that gives me 0.0759. I'm going to add that to my second mass, which is 7.016 approximately. And I'm going to multiply that by that's a decimal, I promise, 9241. So for both of these situations, I am taking my masses, multiplying each mass by their respective percentage, and then I'm adding those values together. So I'm going to use my calculator. I'm going to figure out what values I get. And for the first value, I get 0.457 approximately. I'm going to multiply the next two as well because I just have a small calculator. I'm not going to plug all of it in at once. I want to be very careful because if I plug in the wrong information, it gives me the wrong answer, even if I know what I'm doing, and that's not right. So 6.48 is what I got. I'm going to add those two values up. And that gives me 6.94 approximately. So this is going to be grams per mole. And I'm putting grams per mole because this should be the average mass that you find on the periodic table for lithium. So if you look at lithium on the periodic table, this should be the value that you actually see, or it should be very close to it, at least if this information is correct. So the more accurate this information is, the closer this number will be to the number you see on the periodic table for the weighted average or the average mass.